Today we're going to talk about causal research in marketing. Let's talk by trying to define or get an understanding of what causal relationships are. That's when we're essentially interested in understanding when we change one variable. For example, in the case of marketing, it may be our advertising expenditure. What happens to another variable? So, for example, in the case of marketing, if we're increasing our advertising expenditure or budget, we probably would like to see whether that translates into higher sales, right? So whenever we're interested in looking at relationships between two variables, where we're trying to determine whether one is the reason why the other one changes, and we call that essentially causal research, trying to see what is the cause-effect relationship between the two variables. You can actually see that graphically. For example, here I have a little picture of depicts advertising spend and amount of products sold. And as you can see by the scatter plot, what we will expect is actually what we find. So the higher our expenditure it is, the higher is the amount of products that we're selling. So this is the kind of relationship that we're trying to study. Now, to determine causality, it's not just sufficient to see that there is a relationship. There are actually three conditions that need to be met before we can actually talk about causal relationships. The first condition is concomitant variation, which essentially means the two variables that we're interested in studying, both the cause and the effect, need to move together. Now, one way of checking whether they move together is by observing the scatter plot, like we've been doing so far. Okay, you could arguably use other techniques to check concomitant variation. You might be familiar with the term correlation. Typically, if the correlation is different from zero, it's because the two variables are related. Although you could have concomitant variation with a correlation of zero, but that's maybe slightly advanced, and that would be that there is some sort of nonlinear relationship. If the relationship is linear, like in this case, meaning you can fit a line and it will fit pretty well, correlation and concomitant variation pretty much go hand in hand. That's the first condition for causality. Second condition for causality is that the cause needs to move before the effect moves. Okay, what does that mean? That means that if we're studying advertising and sales, you want to make sure that you change advertising first and then you observe what happens to sales, and not the other way around. Now, this is a problem in the case of advertising and sales because a lot of companies actually set their budget, their advertising budget, by looking at their sales from the previous term, let's say previous quarter, previous year. And if they do that, we are going to observe a relationship between the two variables, not because advertising is necessarily causing sales to be higher, but because we know by definition, by the way we're budgeting, advertising is going to be set as last year's sales, right? So in that case, we cannot tease apart whether it's a cause or not. Okay, so that will be temporal order. And then the last one, and by far the most difficult of the three conditions to meet, which is to eliminate all alternative explanations, meaning the only two things that change were advertising and sales. If anything else changed, for example, if one of our competitors dropped from the market, right, we will expect that to basically cause our sales to go up, and now we cannot anymore say whether the increase in sales is because advertising expenditure increase or because one of our competitors left the market, right? That would be a extraneous factor, something that is outside of the things that maybe we are measuring, or more importantly, that we can control. And because of that, it's hard for us to tease apart whether advertising is what's causing sales or if there is some other factor. Okay, good. If we can actually demonstrate these three, then you can say that you have proved, or at least to some degree check, whether something is causing something else. Okay. Now, what's going to happen is for us to determine causality, the third condition, it's going to basically push us to need to use experiments. The reason why is because eliminating all alternative explanations or all extraneous factors. It's so difficult that the best tool that we have at our disposal, it's an experiment to make sure that we control everything that we can so that nothing else is changing. And because of that, if nothing else changes and the only thing that changes is the variable that we actually manipulated, then it must be that the relationship between the two variables is causal, right? So the experiment also is going to help us maintaining temporal order, right? But that's something that can also be checked in the field, right? But the nice thing about experiments is that they help us minimize extraneous factors, right? Any other thing that could have changed. And that's what we're trying to do with the experiment, make sure that all those are held constant, right? Now, what we're doing in experiments in general is to make sure that we can isolate factors to control everything, to make sure that we don't have any alternative explanations. What we're going to do is we are going to be the ones manipulating or changing one variable, right? In our example before, and that variable will be the advertising budget, but it could be any variable really. Anything that you can control, manipulate, or change, right? That will be, of course, of interest to a market researcher. So what we're going to do is we're going to see, okay, let's change one variable. In our case, we're going to call that variable x, or an independent variable. Let's change that variable and see what happens to the other variable of interest, which will be y, right? That's what experiments enable us to do. Is essentially this idea of manipulating or changing the levels of x, for example, advertising budget, going from $100,000 to $120,000. That will be changing that variable, right? And then see what happens to sales, which will be, in our case, the dependent variable. So we're going to talk about two types of variables, independent and dependent variable. The dependent variable is the one that we are usually interested in. In our case, it could be something like sales, or it could be satisfaction of a customer. Right? There are different variables that we may be interested in. Okay. In our previous example, that variable will be the amount of sales. And independent variables are going to be of different types. Okay. We're going to have treatment variables. Those are variables that we are going to manipulate or change. For example, we talked about advertising budget. A treatment could be, for example, a coupon, right, to create something that didn't exist, right? That would be an independent variable that it's under our control, right? A control is a variable that we use to statistically rule out alternative explanations. Okay, and it's a variable that typically is not related to a treatment. Okay, so in the case of our example before, right, we could have advertising budget as our treatment, and then maybe to control, we may be looking at, for example, the economy, right? For example, you might be looking at GDP growth, just to make sure that if you see an increase in sales, it's not because the economy is growing, right? Because if the economy grows, my sales should grow regardless of what I do with advertising, right? And that will be a control variable for us. Okay. And then there are extraneous variables. Those are also independent variables, but those are not under our control. Those are other things that could be changing. They could potentially explain our results, right? So in the case that we were talking about, an extraneous variable would be, for example, one of our competitors dropping out of the market, right? And that will also potentially have an effect in sales that it's not under our control. Okay. Okay. So the technical reason why we use an experiment is to ensure internal validity. Now, what is validity? Validity is to make sure as much as possible that whatever results you actually get are actually true results, that there is no alternative explanation possible. Okay. So we're going to have two types of validity: internal validity and external validity. Internal validity is essentially that the effect that you find in an experiment, it's actually caused by the variable of interest. Okay, so basically our experiment was successful. Okay, external validity, on the other hand, is when you can take the results from that experiment and you can actually generalize them outside of the context where the experiment was actually performed. Both of them are going to be important, and what we're going to see for the most part is that when we increase internal validity, we're going to lose external validity in the meantime. Let me give you an example of why that will be the case. One way of ensuring that internal validity is high, meaning that the results what we actually find are actually because of the variable that we are manipulating. The best way to do that is to conduct an experiment in a laboratory where the researcher, in this case us, is able to control for all sort of things like the level of noise in the room, that there are no other distractions, and because of that, when you, for example, show a commercial to your customers, that there is a good chance that they are indeed paying attention to the commercial. This will be different that if you did the same experiment in the field, where even if you are airing the commercials on a popular, let's say, TV channel, there's a good chance that people, when they're watching TV, right, they will just take a short break while the commercial is airing, and they might actually go to the kitchen and grab some popcorn, right? If they do that, even though the commercial was aired, and there's a chance that we will measure as our consumer watching TV, if there is a device that measures what channels on the TV, we still will be missing the point, because in the real world there are many other factors that could be interacting with the experiment, like for example the fact that maybe our consumer is interested in popcorn on top of our commercials, right? So this trade-off between internal validity and external validity is always going to be there, and as we're going to see later, there are different types of experiments that we can conduct that will have a bigger strength in one or the other, but there is always a trade-off. Okay. Now, having said that, what we're going to do is we're going to discuss very briefly a few different types of experimental designs. This is essentially how you arrange the data collection to try to maximize the chances that your experiment actually is internally valid. Okay, I'm going to discuss three broad families of experimental designs. Pre-experimental designs. These are usually not considered true experiments, and they have the strength that they are simple to do, as we're going to see with one example. Okay, but they have the downside they don't allow for a lot of controls to make sure that our results are indeed internally valid. Then I'm going to talk a little bit about true experimental designs. These are the ones that a purist might consider more adequate to actually prove that a causal relationship exists. I'm going to discuss one of them. And then finally, quasi-experimental designs, which they tend to have as a strength more generalizability outside of the experiment. And in particular, in the case of marketing, we're going to talk about field experiments and about a particular type of field experiment that is somewhat unique to marketing, which is called a test market. Okay. The advantage of these are, though they have lower internal validity, meaning we don't know if the results that we find are indeed because of what we're doing, at least not to as high of a degree as we will in a lab. They give us the advantage that because they happen in the field, in the real world, there is more chance that whatever we observe will replicate if we actually try to do it, either again or at a larger scale, like in the case of test markets. Now, before I discuss the specifics of these design studies, let me give you a brief introduction to the notation that it's usually used to describe an experiment. Experimental design is a challenging field of logic and math that enables us to collect data that has the best possible properties to determine causality. There are many different experimental design patterns, and in today's lecture we're only going to cover two of them, but there are many more, and all of them have strengths and weaknesses. Now, to understand that, we need to understand what happens in those experiments. So we're going to start with the little symbols that we're going to use to describe them carefully, right? The first one is this O, which essentially means that us, through whatever means, we're going to collect some measurement. Okay, it could be observation, or it could be asking some question to a respondent, or maybe using some sort of device that enables us to collect information. Like in the case of a respondent, we might have a skin conductivity test attached to their finger, some sort of probe that enables us to see the degree of perspiration or sweat in their fingers. That will be a measurement, because we are concretely looking at something that can actually be tabulated in this case. So O is for a measurement or an observation. X, it's in experimental design denoted as an exposure. Exposure to what? Well, if you're doing biology, that might be some chemical agent, but when it comes down to marketing, the exposure will be to a treatment, which in the example that we've been using so far will be, for example, seeing a commercial, okay, or it could be receiving a coupon, or it could be observing a product in a shelf, or it could be having a conversation with a friend about a product, right, and that is maybe prompted by the researcher, right? All those will be treatments, meaning it's something that we as researchers are manipulating or changing so that we can actually measure its effect. That's what the X stands for, the exposure or the treatment. Okay. Then we have EG, which stands for experimental group. This will be a group of customers in our case, or participants in general, that will actually be exposed to the experimental treatment, whatever that is that we were alluding to before. Then we have a control group, demarcated by CG, right? And those are group of customers or participants that are not exposed to at least one treatment. Okay, good. And then the last two symbols that we're going to use, R stands for random assignment, which essentially means that the participants, before they are allocated or assigned to a group, they are randomized to ensure that there is no obvious pattern in who is going to what group, minimizing the chances that the differences that we observe are actually because of some sort of selection mechanism. Okay, something else essentially. And then finally M, which stands for matching. And that essentially means when we select some characteristic of the respondent, and based on that characteristic, what we're going to do is we're going to make sure that the groups have similar levels of that match variable. For example, we could match groups by age to make sure that age on average is about the same across groups. Or you can do the same thing with gender, right? And you make sure that the percentage of males to females is the same across groups. That will be matching. By the way, in the explanations that I'm going to use later, I'm not going to use matching, but if you were to do a more complex experimental design than the ones that I'm going to describe, this is typically used in the literature, and I want to make sure you guys are aware of it. Okay, so let's start talking by pre-experimental designs. Now, the strength of these is that they are simple. Okay, the downside is that they are not very internally valid, and I'm going to explain why in the next slide. Okay, so let's start by talking about a one group before and after design. Okay, maybe that sound is a little bit too much. Unfortunately, it's already there, and I think in the next slides also. Okay, so what we can see here is the description of the one group before after design, and that uses the symbology that I have alluded to in the previous slide. So the first thing that we can see is that there is only one group in this design, so it's a very simple design. There's only one group, So all customers or participants are in one group only, so we don't need to assign anybody anywhere. Okay, good, simple, right? And then what else do we know? We know that first I have one observation, meaning that I measure something at this point, right? For example, I could measure their attitude towards a brand of interest. So let's say that we're conducting a study for Nike, right? So we will ask them some questions about what they think about Nike as a brand first, right? And then we will do something which will be a treatment. As you can see here, X standard for treatment. So for example, we could show them a YouTube video, and embedded within the YouTube video there is somebody that is a famous person and it's wearing a Nike t-shirt, for example. I don't know, maybe LeBron James, right? Okay, so that will be our treatment, right? And then we ask them again some questions about Nike, okay? And to be precise, both typically the questions that we ask first and second will be the same questions so that we can compare them. Okay, and then what we're going to do is we're going to determine what is the effect of that treatment by looking at the difference between O1 and O2. Okay, so we will measure here, we will measure here, we will take the difference between those two measurements on average, if we have more than one participant, which hopefully you should have, right? And that will dictate whether our treatment, in this case, seeing a video with a t-shirt from the brand of interest, right? That will be considered product placement, by the way, from a marketing perspective, whether it's actually useful or not in determining your attitude towards the brand. Okay. Now, what are the problems with this design? The problems with this design is there are many things that could be going on other than whatever we observed here. Let me discuss a few things that could be going on. I mentioned the effect of that. Let's go to the issues. Okay, good. Now, what could be happening here? Well, the fact that we are measuring at 2 time points the same group like we were. So if you remember, there was only one group, experimental group, and that experimental group is measured in the beginning. Then there is a task given to them, in this case a YouTube video, and then it's measured again. Now, it is possible that between the first measurement, O1, and the second measurement, O2, there is something else that changes outside of the experiment. For example, imagine, for argument's sake, that between those two measurement points, could be maybe 10 minutes apart, right? There is an external noise that comes into the room. Maybe there is somebody cutting the grass outside of the office where this experiment is taking place, right? What that will do is it will potentially alter the results of the experiment. And we call that threat to validity because we won't know if the results are because of the experiment or because of the noise induced by the lawnmower, let's say, right? We call that history because it's something that is changing outside of the experiment but actually influences what happens to the experimental units, in this case to the experimental customers, right? Good. That's one thing that could be going on that will basically threat our results. We don't know if the results are accurate anymore. What else could happen? It could be then during those 10 minutes, your respondents could change. We call that maturation, where there is essentially an effect such that the respondents over time, they're changing themselves. What could be happening? Well, for example, when you ask the same questions twice to people, they learn, right? And as they are learning, maybe you're going to answer the question slightly differently because you're asking the question twice. Maybe they get bored with the question because they already answered the question just 10 minutes ago, right? So that's also a maturation effect, right? And we won't be able to know if the response to our treatment, in this case the YouTube video with the product placement on it, it's actually what's driving the results, or it's the fact that the units are changing over time. When I say units, I'm talking about customers in our case. Okay. What else could be happening? Something else that is an important threat to validity, that in this case is probably not an issue, is selection bias. And that essentially means that the people across different groups are actually different. In our case, because there is only one group, we probably don't need to worry about this. Although, to be honest, how our customers, the ones that are in our experiment, are selected could also be potentially a selection bias issue if they are different from our population of interest. If they are not, then selection bias in this case will not be a problem. The fact that there's only one group minimizes selection bias in many ways. So this is probably not a large concern. It's concern in other experimental designs. Then we have mortality. What is mortality? That's essentially when some of the customers, in our case, or experimental units, do not complete the experiment. Something happens to them, like for example, they get bored and tired and they quit the experiment. If the people that quit the experiment are different in any way from the ones that don't quit the experiment, then the results that we find, we don't know if they are because they are true results or because we have mortality. When you have multiple measurement points over time, there is a chance that mortality will be an issue. Of course, that terminology, mortality, comes from the medical field, where patients literally die between measurement points, and that, sadly enough, happens. But in this case, what I mean by mortality is that maybe they just stop providing answers for us, or they just drop from the experiment altogether. They might still be alive, but they just quit. They decide that, you know what, I don't want to answer more questions. Okay, good. And then finally, there are testing effects, and you can get into details of this, but essentially what I'm going to say is just the fact that the customer knows that you're observing them changes their behavior in some predictable way. If that's the case, then we don't know if the results we're finding are internally valid or not. Now, the way we set up the experiment, this is not necessarily the main concern, but it could also be the case. Okay, now let's try to come up with a better experimental design that at least accounts for some of these problems, because we want to minimize these problems as much as we can. Okay, good. Let's try a slightly more complex experiment that does a better job at providing internally valid results. So here you have a two-group after-only design. Okay, now what does that mean? Well, like the name indicates, and like hopefully you can see here, we have two groups instead of one like we had before. Now we have an experimental group. Experimental group, by definition, means that they are at least exposed to one treatment, right? And we have a control group. Okay, so we know we have now two groups. We used to have only one. Okay, now, because we have groups, what we're going to do is we're going to try to minimize the chances of having selection bias, and the way we're going to do that is by randomly assigning our participants to these two groups. So instead of choosing the people that show up first to group one and the people that show up later to the appointment at the lab in the other group, what we do is we actually randomize. This can, in a case of two groups, be simply assigned people by flipping a coin first. Of course, you can do this ahead of time using some random number generator, which I'm not going to explain in class, but if you're interested, you let me know. I will be happy to go over with you over this. Okay, so we do that to minimize the chances of a difference be explained by our assignment. Okay, and then what do? To the experimental group, we give the treatment. So in this case, it could be we'll show them the YouTube video with LeBron James wearing a Nike shirt. And then we ask them the questions about Nike. What are their attitudes, right? And to the control group, notice X is absent, so they do not watch the YouTube video, and they just answer the questions about Nike. What are their attitudes towards Nike? And now we measure the effect like we did before, the difference between those two measurements, observation 2 and observation 1. Okay. Now, notice the fact that now we have these two designs, what we are able to do is we only measure participants once. So this is going to lower the chances that A, something changes in time, like history, and it affects our results because everybody's been measuring time at the same point. Okay, that's one. Another thing that this minimizes is by only measuring one time, it enables you to not have a problem with respondents changing over time, right? Because arguably they spend less time in the experiment. Okay. Also, the fact that they do not get measured twice, it's going to minimize the chances that the observation itself or the research itself is going to trigger changes in the respondent, right? So what we're doing with this design is we're increasing complexity. Now we have two groups where we used to have one. We need to do some random assignment. But on the other hand, we actually minimize some of the threats to validity that we didn't have before. This is technically a true experiment, and because of that, it tends to give you more internally valid results. Okay, that doesn't mean a cell is always better, because maybe it doesn't have the same external validity, right? But you gain something, you lose something. Okay, good. Now, when we're talking about internal validity versus external validity trade-offs, I really want to talk about two different types of experiments: lab experiments versus field experiments. Now, lab experiments are typically conducted in a controlled scenario, right, in a laboratory, which are nice because they enable you to control for a lot of things, like the temperature, any external stimuli, right? So what you're doing is you're minimizing all those potential threats to validity. However, the downside of a laboratory setting is that customers might not feel at ease, or they might not behave in the exact same way as they will in the wild, let's say. So because of that, what will happen is that the generalization from the lab to the real world scenario might not always be warranted, right? So what we gain in internal validity, we're going to, some degree, lose in external validity. So you have lab experiments which have high internal validity and, let's say, lower, maybe, external or generalizability, external validity. We have also field experiments. Right? Now, what field experiments enable you to do is to conduct experiment, meaning manipulating some variables, in the wild, in a natural setting. Okay. Typical example of this will be a test market, which I will discuss into a little bit more detail into the next slide. Okay. Now, what is the advantage of a field experiment? Like I said before, high generalizability. You are in the wild, so because of that, applying what you did in this city to the entire market might actually make sense, right? Because maybe that city is representative of what happens elsewhere, right? Now, what are the downsides of that? One, you have less external validity. One of your competitors might hear that you're introducing a product only in Pittsburgh, for example, and they might actually tinker with the pricing just to screw with your results, right? And if they do that, I don't know if the results that I'm getting are indeed valid, internally valid or not, right? That's one thing, so lower internal validity. What else? It's much more costly than conducting an experiment in the lab, right? If you're going to introduce a product, you could just do it in the lab, in a small setting. You only need to produce so many units to do that, right? Or if you're going to introduce the product in Pittsburgh, right, you're going to have to make a lot more products. Making that product when it's still maybe at a prototype stage might be quite expensive because you don't have economies of scale, right? Plus, you need to get all the marketing variables together and right. So you'll have to do advertising or any other support that the product actually needs, both on the shelves, let's say at the store, and the rest of the marketing mix variables, right? Also, it takes time for the results to actually sink in. There are a lot of effects in marketing that build over time. So typically, field experiments are conducted in a much longer time frame than a lab experiment. And finally, although I've already alluded to it, it is obvious that the moment that you move to the field, your competition can actually learn about what you're doing. So you lose that secrecy that the lab potentially provides. Finally, let me, even though I've already alluded to it, talk a little bit about test marketing, which is the most, I don't know if I want to say unique, but the most representative field experiment that is done in the marketing field. Now, test market is typically done when there is a new product that is going to be introduced into the market. But because of the risk associated with new product failures, what we oftentimes will see in the market is companies trying the product introduction into a few cities. In the US, there are some cities that are designated as test markets. And the reason why is because they are supposedly, by looking at some variables, they are representative of what happens in the entire country. So whatever you find in, let's say, a 6-month introduction in 2 or 3 of these cities should generalize pretty well to the entire market. Now, you can use test markets not only for introduction of new products, although that is usually the most common use of this technique, but it can also be used to check other marketing mix variables, like for example, if you want to do a radical change in pricing, or you want to use different channels of distribution. Okay. Now, in a situation like this, the idea of a test market is you're conducting a field experiment, right? In the case of a new product introduction, the variable that you are manipulating is whether the products actually launch in a city or not, right? And you're trying to see whether the sales that you're actually getting in that case are good enough for you to promote the product from a test market to a launch at the entire market level. Okay. So typically the objective that you're doing, or the variables that you're looking at, is sales, either in units or dollars or both. Okay. And you might also be monitoring other variables of interest, like for example customer satisfaction, any customer behavior / reaction to the introduction of the product, of the change of the marketing mix, could be of interest. Arguably also, and this can be useful to make sure that there are no adverse consequences to, for example, brand equity, right? It could be that if you're launching a new product that is a much cheaper version of what's already in the market, that could actually erode your brand equity, right? If you're a brand that has built a strong brand over the years, now launching a cheap version of your product might actually be damaging to your brand. So you might be able to measure these effects in a test market before you roll the product nationwide and you actually do some serious damage to your brand. Downsides of test markets, like I've alluded before with field tests in general, is that they are usually very costly. It's usually a multi-million-dollar exercise. And also that the typical test market will last 6 months to a year and a half. So it's not something that you collect quickly. You need to give it time to make sure that everything is working appropriately, and then see whether the results are appropriate or not. That's it for today.